They announced that they identified the very first molecule ever to be created in the universe. They found a molecule that was formed immediately after the Big Bang. Astrophysicists were able to see what appeared long before the birth of the first stars and planets. But how in the world was it possible to find this 13.8 billion year old microdust? More importantly, if we found the very first molecule, what other secrets and mysteries does our universe hold in store from the moment of the Big Bang to this day? The name of the first molecule in the universe is the helium hydride ion. This is a compound made up of a helium atom and a positively charged particle of hydrogen. It's not so easy to find a molecule in this particular combination, despite the fact that hydrogen and helium are the most common elements in the universe. There are at least two reasons for this. First, helium is an inert gas and by nature is not eager to react with other elements. Secondly, unrealistically high temperatures are needed for the formation of the first molecule, which today are difficult to find in our universe. According to NASA data, the first second after the Big Bang, temperatures in the universe reached 5.5 billion degrees Celsius. That's about 10 billion Fahrenheit. Because of this extreme heat, elementary particles, protons, neutrons, and electrons moved so fast that they didn't have time to form bonds. So only when the universe cooled to a meager 3,700 degrees Celsius, or about 6,700 Fahrenheit, were a helium atom and a positively charged hydrogen ion able to form the very first helium hydride, which scientists have been searching for about 100 years now. The first significant success in this research was achieved in 1925. At that time, physicists managed to recreate helium hydride artificially and thus obtain the strongest acid of all known on Earth. But the artificial connection was only a small victory on the way to the main goal, discovery of the real first molecule, originally from space. It wasn't until 45 years after the creation of helium hydride in the laboratory that scientists decided to look for it in conditions as close as possible to the Big Bang. That is, where there's extra high density and it's very, very hot. There aren't many places meeting these requirements, only about 3 to 10% of the whole universe. These conditions exist in planetary nebulae. They form when heavy stars with a mass like that of our sun die. At this point, all hydrogen is burned out in their center. The core is compressed to an incredible density, and the outer layers, on the contrary, expand. When the connection between the outer layers and the core becomes catastrophically weak, the star collapses. From now on, the star is called a white dwarf, and its former shell is a hot planetary nebula that's ideal for the formation of helium hydride. Scientists just had to choose which nebula to explore. They made a bet on NGC 7027, a nebula at a distance of about 3,000 light-years from Earth. Its central star is one of the hottest stars in the universe. According to scientists, the star collapsed just about 600 years ago. However, it's still hot enough for the first molecule to be found. Guided by these facts, NASA pointed its stratospheric observatory, SOFIA, to NGC 7027. This is actually a telescope on board a Boeing 747 SP. It rises to an altitude of 45,000 feet, or almost 14 kilometers. This allows the telescope to record data as accurately as possible. In 2019, in the dust of a distant planetary nebula, SOFIA finally discovered the very elusive and long-awaited helium hydride molecule. NASA proudly published a statement that they had found the first molecule formed in the universe. The world held its breath with anticipation of the news. How will this finding affect our understanding of the universe? What results and new discoveries will this lead scientists to? But already the research that has followed made all fans of the world of science sigh in disappointment. It turned out that we can never actually see this first molecule. The fact is that after the Big Bang, the universe expanded at the speed of light, and its temperature and radiation level decreased with time. This means that the conditions necessary for the formation of helium hydride disappeared too quickly. So by the time the universe turned 500,000 years old, its first molecules simply broke down. The helium hydride molecule that people saw in 2019 is probably already a new entity and has nothing to do with the early universe. But scientists didn't get discouraged by this. They persevere in their research and make no less impressive discoveries. For example, last year, physicists from Indiana University of Bloomington discovered a unique substance capable of destroying our planet with one blow. Just imagine, enough power to destroy the entire planet in one shot. But before I begin my story about this supernatural force, I want to introduce you to the sponsor of this video, the online shooter Crossout. It's a game where you can fire your enemy from a car customized by you and built just the way you want it. Laser and plasma guns, tank tracks, and rocket boosters. These are just a small sample of the huge arsenal in Crossout. Your battle car will look cooler than an explosion of a neutron star. Follow the link in the description immediately after watching this video and download Crossout for free. Just for you, my favorite subscribers, the game developers have prepared a special bonus, a selection of 3 weapons or a van cabin. After all, Crossout is great on the PC, Xbox, and PlayStation. Learning to play Crossout is so easy that even your neighbor's dog can figure it out. And most importantly, you'll be so into the game that you won't even notice how the Earth begins to disintegrate by a megaforce explosion, which I'll tell you about right now. Scientists have suggested that when dying stars explode, they release a multitude of neutrons. These neutrons are pressed so tightly together that they form bunches of nuclear matter. They're in the shape of drops, tubes, or sheets. Because of these particular shapes, they receive the names of their counterparts from Italian cuisine: dumplings, pasta, and lasagna. But simple names hide supernatural properties. Although it's impossible to study their substance physically, scientists applied mathematical modeling and obtained shocking results. It appeared that this nuclear pasta is 100 trillion times denser than water. If you want to tear it, you have to use a lot of force, 10 billion times more than is necessary to destroy steel. According to the assumptions of physicists, a cubic meter of such a pasta would weigh more than our entire planet. Such a mass would allow it to pierce the surface of the Earth to the very core in 1 second. Can you imagine what would happen if someone decided to order a whole portion of such a dish? Honestly, its presence on the menu of our universe is based only on scientific assumptions. Scientists have yet to finally prove the existence of this nuclear pasta. But according to their calculations, these clots of matter can cause low hills to form on the surface of stars. Once we are able to aim gravitational waves near them, that is, oscillations in space, then the existence of this most durable substance in the universe will be proven. We can only hope that the discovery of this amazing material will not suffer the same fate as Stephen Hawking's theory of dark matter. Stephen Hawking's theory of dark matter made a lot of noise in the 1970s, just as much noise as the discovery of the first molecule and the ultra-strong substance today. Hawking stated that dark matter is an invisible substance associated with tiny black holes. For years, scientists have been trying to find evidence for this statement. They hoped to discover those same black holes when they explored the Andromeda Nebula, the closest galaxy to Earth. But it turned out that the share of these black holes accounts for less than 1% of the matter, which means that Hawking's theory has not been proven. But Hawking still played a major role in the discovery of incredible substances. After all, his assumptions, although indirectly, still help scientists to prove the existence of an atom on Earth, which can take up to 18 sextillion years to disintegrate. This is about 3 billion times the age of the universe at present. Let's agree that this sounds even cooler than the world's first molecule. We are talking about xenon-124, a very unique radioactive isotope. Scientists have tried to determine how long it takes to break down since 1955. They were able to achieve the result only with the help of a detector, which was created specifically to investigate dark matter. In other words, if it were not for Hawking's disastrous theory, there wouldn't have been a super-sensitive, powerful detector that captured the unique phenomenon of the decay of xenon. For almost a year, this device, Xenon-1T, collected data, on the basis of which scientists made a sensational conclusion. Xenon-124 is the longest living known isotope in the universe. Therefore, if we want to send a time capsule to our descendants, the most reliable message must be preserved using xenon. Honestly, though, our descendants probably won't be too happy about the dose of radiation they will get as a bonus. Anyway, the discovery about the decay of Xenon-124 proves once again that our universe